Hey, everybody. We are going to get started. As you might have noticed, your camera is unavailable if you're an attendee. And this is a Microsoft Town Hall event, which means that you'll be able to access the Q&A. And so we highly encourage all attendees to ask questions. We formatted this town hall such that each individual speaker will leave some time at the end of their session to address some questions. Um, we have our planning manager from DCA, Julie Yoder, on the call, and she'll be perusing the Q&A and then bringing those up to our speakers. So we're very excited to kick us off right away with Melanie Bruggeman, and she is the business development manager at Archer Western. And excited to hear her set the table for our discussion today. And her session, just like the rest of the sessions, will be about a 15-minute presentation. So nice, short, and sweet, leaving time about 5 minutes per speaker to address the questions that you all may have. Our goal with this webinar at DCA is for local government representatives to speak on successes and challenges of recent water and sewer infrastructure updates to help other local governments, the people on this call, with learn the best practices, how to overcome challenges, and to overall better serve their current and future residents. Our hope, DCA, is that we can provide a platform today to share learnings and that successful projects from around the state can be replicable in other communities. And so with that, I'll hand it off to you, Melanie.
Thank you, Daniel. I'm going to share my screen and let's get to the slideshow presentation. So can everyone, or Daniel, can you guys see this? Awesome. So like Daniel said, I'm Melanie Bruggeman. I'm with Archer Western. I just started here about 3 weeks ago, but in my previous life, I was an engineering consultant for the last 12 years. Um, I've been involved with GAWP, which is Georgia Association of Water Professionals, for many years. And just a few accolades. I've been inducted to the GAWWA Golden Hydrant Society and GWEF. GWP. Yeah, there we go. And then GWEF 5S inductee. And basically been doing this a long time and really excited to tell you guys a little bit about water and sewer. So this is a little elementary, but you'd be shocked at how many people do not know the general process of the water cycle. But we first have rivers and lakes, and from there, the rivers and lakes, there's evaporation, condensation clouds, precipitation, and then it goes into our rivers. We pull water out of our rivers and lakes to treat for water distribution, and that goes to the homes of all of our citizens. And then what comes out of their homes goes to a wastewater treatment plant, and that returns back to our rivers or our waters. It may sometimes be land applied, which then is absorbed and actually makes its way to the rivers. So when we get to water and sewer, ownership kind of becomes a question. Most of the time, our water and sewer is owned by the public, meaning it's owned by the city, county, or a local authority. There's a few times that we do get into the private ownership, which would be when the developer has installed a water and sewer system for a neighborhood. Sometimes the HOA may own it. And then other times the homeowner may own it. But most of the time we have it as a public ownership. This image right here is very good. I would say this represents about 95% of all utilities. So for the water, you have your street, and just imagine that the main line pipe is going in and out of this page. But the city owns all the water piping all the way to the water meter, and that is where the homeowner takes ownership and the water pipe goes to their house. The water meter makes a really good delineation of who owns which side. And then for sewer, the homeowner owns all the way to the main line. Sometimes you might have a utility that has a sewer that owns to the right of way, the public right of way. but sometimes that gets a little, uh, you don't really know where the right of way is, and sometimes the owner fights about that. So most of the time, a utility will own all the way. I mean, the homeowner owns all the way to the mainline connection. So some types of designs that we'll kind of go over is water, which is municipal supply and private wells, and sewer, the municipal public sewer system, septic tanks, and I will briefly go over low pressure sewer systems. So when we get to the water system, there's different ways to design this and different types of designs. So the first one we look at is water treatment plants. When we design water treatment plants, there's a lot that goes into this. But for the most part, most of them include pulling water out of a reservoir or our lakes and our rivers. And we're going to have a treatment process of sedimentation. We are going to filter it. And there are a lot of different ways to filter the water, whether it's through, old school gravity sand filters, or if it's through membrane technology. That's what a lot of people are going to. And then we will disinfect the water, and then it usually gets pumped out to tanks within the system. So that's how it gets into what we call the distribution system. So when we're designing pumps, we need to design to meet a specific pressure within the water system. And with that water system, you have two different types of pressures. One is the domestic pressure, which is what you get out of your faucet. And another one is for fire flows, which is what comes out of our hydrants. So we have designed our pumps to meet those two pressures. A lot of times we will pump all the way to a storage tank, and so then we're using less energy because the storage tank provides pressure via gravity. So we design storage tanks based on the height and the size of how much it can hold. So the size is typically for 24 hours worth of storage for that community. So, if a community has 100 people and it needs, let's just say it needs 100 gallons per minute, then we have to design it for 24 hours of storage. And then distribution system, when we're designing the distribution system, that mostly includes all of your pipes that are going to the houses and maybe a few booster pump stations throughout the system. But we have to size the pipes based on the amount of flow. And then the pipe material is something we design. And that a lot of times that's based off of what the actual utility would prefer. So most of the time it will be ductile iron or PVC. So some constraints that you may come across as an elected official or someone who might be involved with the water and wastewater distribution and collection systems is water treatment plants. If you plan to design a brand new water treatment plant, it needs to be located near a supply. So whether that's the river, a lake, a lot of times right now, if we can't get as close to a river or lake, we're having to build very large reservoirs and pump the water from the river or the lake all the way to the reservoir. So, for example, that just happened in Paulding County. They opened a very large reservoir. Another thing that kind of becomes a constraint when we're designing a water treatment plant is the droughts. We have to monitor those and understand how we store water in a drought season. I know we get well, as water and sewer people, the state kind of puts the hammer down when we're in a drought season to conserve water, and that ends up going on your local citizens. So that's another constraint that we have to look at when we're designing water treatment plants. When we're designing distribution systems, some constraints that we have are the pressures. We have to maintain a specific pressure throughout the system, and we have to make sure that we have enough redundancy so that if there's a water main break, that a whole county or a whole city is not out of water. But those are the kind of the main constraints to think about whenever you're looking at the water system. So now we're going to go into water wells. Some people, if they aren't on a public water system, they will have a water well. And these are typically in rural areas and they utilize groundwater and they have kind of a filter casing, which is almost similar to a water treatment plant, but it's just on a much, much smaller scale. So if you are in a rural area and most of your residents are on a well, this is what it would look like. Some constraints with that are it's really hard to dig a well when you have a lot of rock. Sometimes sulfur will make the water smell, have a bad smell and kind of an odd taste. And then if you have a fluctuating water table, this also limits kind of how you can get a well. So now we'll move on to sewer. So when we're designing a sewer, we look at a collection system, which is what the piping that goes from people's houses and all the way to the wastewater plant. So when we're designing this, we need to look at pipe material, again, that is mostly based on the utility and their standards. Another portion of the design is whether we're flowing the sewer by gravity or pumping it. We prefer not to pump it just because that does require a lot of energy and a lot of operation and maintenance costs. Where gravity sewers, they flow by themselves for the most part. If they do get clogged or backed up, it just requires a one-time cleaning. When there is a backup versus pumped, it's being pumped all the time. And the pumps get a lot of rags, if you know what rags are, or the flushable wipes that are actually not flushable. Our pumps get clogged with those. So that becomes a little bit more difficult. When we're designing the pumping system, we need to look at the force main. We have to size our force mains based on the flow and the velocity. We like to keep those what we call self-cleansing, so we don't have to clean them out often. And then when we're designing the pump station, we also have to think about when there are rain events. Rain sometimes gets into our pipes, which is called I&I, which is infiltration and inflow. And so during rain events, our pumps at our pump stations are having to pump way more than they typically do on an average dry day. So we have to design pump stations for both low flow and a high flow scenario. Again, I&I, infiltration and inflow, we do get those in our sewer system. Everything's underground, so we don't necessarily see all the small cracks or maybe sometimes you might get a manhole that has holes on the top. So that's where we get our infiltration and inflow. Then when we get to a wastewater treatment plant, we kind of talked about earlier how we have to design those. That usually includes some sort of screening, which takes out all the trash because we do still, even though it's a sewer, we do still accumulate quite a bit of trash. So we typically have to screen our wastewater when it gets to the plant. And we screen that and we throw the trash, we take the trash to a landfill. Once we get there, depending on what kind of system you have, it's typically a biological type system. We have to aerate the sewer, and then then it goes to clarifiers where the solids kind of more settle out, and we get a cleaner water that skims off of the top. From there, we typically do disinfection before it goes back into the rivers. And I know a lot of people think that clean wastewater going back into the rivers might sound like there might be some, E. coli or anything like that, but the state does require very high standards of effluent treatment. And a lot of times what we are putting back into rivers and lakes and streams is much cleaner than what is already there. So I like to say that we are bettering our waterways with our wastewater. There are some instances that there might be a spill or an effluent violation, but those are very rare. And we have a lot of, with Georgia EPD and the river keepers, there's a lot of people that are watching that to make sure that they don't go unnoticed. And then, like I said, disposal, we may discharge into a river. That would be a direct discharge permit. You could also discharge through land application. I know the city of Covington has a really large land application system, and what you can do is you spray it in a field, and basically the land absorbs the wastewater and it ultimately gets to our waterways. But what the city of Covington does is they grow, I think it's pine trees or some sort of tree, and they harvest those trees. And so they really are kind of very environmentally friendly with their wastewater discharge. Another way to dispose of the wastewater is water reuse. So I know Paulding County, they have a water reuse. And basically what that is they take the treated wastewater and use it for irrigation in locations. The wastewater discharge there has to be disinfected to a certain degree for water reuse. But yes, it can go to irrigation. And so I know they irrigate a few golf courses with their treated wastewater. So some typical constraints with sewer is, again, your wastewater treatment plant needs to be located near a river for discharge. Or if it's not, then you have a really high pumping cost to pump it to the river or the stream. So that makes it a little bit more difficult. One that you guys most of you may know is where you place a wastewater treatment plant in neighborhoods. You have a lot of complaining citizens and a lot of residents that may not like the smell and the odor. So it's kind of hard to find those specific locations for wastewater plants. And you also want it to be in a centralized location. And a lot of times they are located at the lowest point so that the gravity of the sewer can make its way all the way to the wastewater plant. But you want to make sure it's somewhere that's not so far away that you're pumping sewer for miles and miles and miles to get to the wastewater plant. With the land application, you don't want to do land application if you have very steep slopes, because all that does is create erosion, which is not great for our environment, and rock. It's very difficult to have land application if you have rock, because the wastewater does not seep into the ground like you would like it to. And then some constraints with our collection system is how shallow or how deep our sewers are. We kind of have to battle as design engineers of how deep we want to get a gravity sewer before we decide we need to pump it back up. So sometimes, I've done gravity sewers that are almost 30 feet deep, which isn't ideal, but may be required, just because that's very hard for a utility or a city to operate on, because they don't usually have the manpower to dig 30 feet down in the ground. So we have to be mindful of that. Some constraints are pump stations, when and where you have pump stations. I know if you have a very, very developer friendly, or maybe a community that has a lot of developers coming in, they tend to just want to do a pump station because it's easier and cheaper for them to design it, their sewer system more shallow. But what happens is it ultimately gets turned over to the utility, and you don't want a whole lot of pump stations as a utility because they are a pain. They do get messy. They do get clogged up. You have to replace the pumps often, and they do require a high operation and maintenance cost and electrical costs. And then lastly, this is for both the wastewater treatment plant and the collection system, is really odor control and how you make sure that your residents aren't smelling the sewer on a day-to-day basis in your sewer system. So real quick, I don't want to get too in the weeds of this, but when we do design a water and sewer system, we are designing it based on some assumptions, and the assumptions can range, but for the most part, we're designing water based on what our residential flow rate is, and we design that based on a gallon per day per capita. So that would be essentially per person. Um, and then we have to assume how many people are in each household. So there are a lot of assumptions there, but if you look, some people have very sophisticated data, and we can use their data, existing data. So it used to be 100 gallons per day per capita, but it's starting to look closer to about 67 gallons per day per capita, um, based on, we have low flow toilets and all these water saving technologies. Fire flows, a lot of times we're designing based off of the design constraints. So 500 gallons per minute in rural communities, 1,000 gallons per minute in urban communities, and 2,000 gallons per minute for large developments or industrial sites. And we have to have a design fire flow at that rate for an hour. Sewers, we typically design them to be 60 to 85% of the used water, knowing that pretty much if you're at your house and you're running your dishwasher and your sink and your laundry, that pretty much all of that water goes to the wastewater system. So you're only consuming about 5 to 10%. So we do have the domestic wastewater, we have commercial wastewater, and then we have recreational wastewater. So if you're looking at a golf community or a park, in the summer, they're using a lot more water for the irrigation. And then a few other design considerations to think about is permitting. If you are doing a water or wastewater permit, you do have to get the withdrawal permit or a discharge permit. And those take a very long time to get from Georgia EPD. There's a lot of testing of the rivers and lakes that you're pulling water from or discharging wastewater to. So those do take a long time. We do have to make sure that when we're doing any clearing or anything like that for our projects that we're looking at protected species. GDOT permits, if we're putting anything in GDOT right away, we have to get a permit for those utilities. Creek crossings, we have to get specific permits from United States Army Corps of Engineers for that. And then all of that takes a lot of time, and we have to coordinate with other utilities like Georgia Power and AT&T Fiber. So things like that, you're always having to work with other utilities since it is kind of a mess under the ground. And then sewer infiltration and inflow, we're always kind of having to deal with that as we as our infrastructure ages and we're having some more issues. So some big takeaways is you need to understand your local planning. So who owns the water and wastewater system, whether it's your state, your county, your local authority. And if you are buying or selling water to other communities, you might need to know who's involved in where your water supply is coming from. We have to utilize accurate capacities. So if you're planning a community or planning a development or know that there's areas of your community that might be growing or developed, kind of converting that land planning into water and sewer planning. So understanding, is this going to be an industrial site? Is this going to be a residential site? And then planning accordingly for that. And then review constraints. Sometimes I get a lot of land planners that will want to go up and they'll want to be like, oh, we think that development would be great in the north part of the county. And I'm like, it's completely all rock up there. So it would be very expensive to get water and sewer up there. And that's just not going to happen. So kind of understanding your geological constraints and your where the location of your water and sewer system are, permitting constraints, topography, and capacity of how much water and sewer is actually available from your utility to serve those areas. And then I have a helpful resources. These are a few places that I go to regularly to figure out some water and sewer design. So if you want to take a picture of this screen, I find that to be very helpful. And I think that's all.
Great. As I said in the chat, all of these slides will be made available to everyone following this. And we're also going to be posting this recording on our Success Stories website. So check that. I dropped the link in the chat as well. So with that, I will leave a about 60 to 90 seconds for any questions that you may have of Melanie. Didn't see anything in the Q&A, Julie.
No, I haven't seen any questions come through yet.
Must mean I covered everything well.
You really did.
Or fast.
He's a pro. Okay, Melanie. I think we're going to say goodbye and we're going to move on to our next speaker. Thank you so much for that in-depth look. I mean, I know it was short and that you just scratched the surface, but it was great and really robust. So thank you, Melanie. We're going to move on to Southeast Georgia, city of Waycross, and we have an engineer named Trey Gavin as a part of ESG Engineering, who has been helping provide engineering services, consultant services to the city of Waycross for several years now. And I will be quiet and let him begin his presentation on their updates.
Hey, thanks, Daniel. Can you hear me okay? And is my screen sharing?
I can hear you great. And your screen is now sharing. Trey, take it away.
Okay, thanks. Yeah, like Daniel said, Trey Gavin, work with ESG Engineering and have worked with the city of Waycross as their city engineer for going on, I guess, close to 5 years, 4.5 years. Came on just before COVID, if that places the time frame, right? And really excited to present to this group some of the stories of planning and some of the stories of infrastructure success for the city of Waycross. I'm going to jump right in. About the city of Waycross, it is the county seat, and we are the only incorporated city within Ware County, around 2 square miles, 14,000 or so people in our area, more than that served by water and sewer, as we are one of the primary treatment providers in the area. Median household income is $31,000, and this is a commission manager form of government, 5-member city commission, mayor elected at large with a city manager. The city of Waycross, like so many of our cities in the state of Georgia, their water and sewer systems were constructed in the 1960s for the most part, some older than that. 60 years old. I don't know about the rest of you, but 1960s doesn't seem like it should be that many years ago, but it is indeed. City recognized the need to address this snowballing situation with infrastructure around 2019 and worked with ESG Engineering to develop a 10-year master plan, capital improvement plan for water and wastewater systems. This does jive with some of the comprehensive planning that the city and Ware County had joined together for both a regional water plan and the updated joint comprehensive plan. And you can see here planning concepts that moved into proposed projects within that plan were hitting all around water, wastewater, street and drainage, that we would start to address some of the capital improvement program items that were listed. We continue to address deteriorations and make capital upgrades, and that community facilities would be be sure to have adequate community facilities with water and wastewater. Additionally, there was a goal to extend water, sewer, and other utilities to the industrial park and other areas that are suited to economic development. So we did have an economic development driver as well within the planning. 2019, 2020, it looks like 2019 based on my dates here. And I know this could be small. I'd be happy to provide more detail if someone were interested. But the capital improvement plan listed out mostly rehabilitative and regulatory issues. The city has had a declining population for quite some time. And so the not a whole lot of focus on growth. We had a couple of growth slash redundancy measures here, but looking at potential for regulatory issues we might be facing over the next 10 years, plus looking at concepts for rehabilitating many systems that were in need. We also had a yearly rehabilitation budget built in, whereby we would start to address old hydrants and valves, replacing those for obvious reasons, and also infiltration and inflow reduction projects, which Melanie described very well a bit ago. We all know that these systems aren't getting any better with time. We've just got to start addressing this on an ongoing basis, on an annual budget perspective, or a big capital project. So in this case, we kind of programmed it with all the other needs. We programmed these particular needs as like an annual budget. The overall 10-year drinking water capital improvement plan was much better than the wastewater, which we find is typically the case, not always. 2.6 million, and then we had a 10-year wastewater capital improvement plan for 13.4 million. And I would just point out that these are pre-COVID numbers, and I think we all know that things have escalated rapidly since then, especially in those first couple of years of COVID. And we would guesstimate a 2x to 3x on these numbers by now, certainly a 2x. So the key projects that came out of this exercise that were high priority for us to face, both from a technical perspective for engineering and also for from a funding perspective. Planning's finished. Now we're into the nuts and bolts of how to make it happen. Drinking water, an interconnecting pipeline between what we call the city system and the industrial park system that would provide source and delivery redundancy was a key project on the drinking water side. This particular project, we have two different permitted systems that are disconnected by several miles. And in this case, just recognize the need to be able to move water back and forth rapidly and provide redundancy and additional source water capacity to the city system. So this project was planned as a high priority. Expand source water capacity through a new well field, SCADA improvements, and then just an ongoing effort to replace undersized and leaky mains. So both capacity and a problem with non-revenue water or losses of revenue water. These are tracking mostly with mains that are still asbestos cement, which we want to get out of the system and galvanize, which I'm sure many of these cities and counties suffer from galvanized leaking and other issues. On the wastewater side, these are mostly attributed to the wastewater plants and the lift stations is where most of these projects originated. Lift station evaluation pump replacement program, addressing key areas of the wastewater plant. We had structural issues on the carousel with the structure wanting to bend outwards due to an issue with a previous design, not my company, previous design that we needed to go out and address, and then sewer rehabilitation. So our strategy here for funding, and I don't want to get into too much detail here, but suffice to say it was a multi-year, multi-tiered process that started in 2020 with a pre-application. Then I know many of you have utilized GFA funding, and if you are labeled as a disadvantaged community, hopefully you've been receiving principal forgiveness. You can see the projects listed on the right-hand side of this table, and I think the big takeaway here is that our specific strategy led to a $5.625 million of grant for $12 million worth of work, which is pretty amazing in this marketplace to find that level of grant, 45%, I think, or something close. again, we're addressing the highest priority projects that were determined from the planning process, and that's the key. ESG Engineering also completed a rate study that included both a rate increase recommendation and also came up with some impact fees, which I know is a dirty word in our business, but it's service system development charges that would give the city as it grows, which has happened in the last few years. Good news for the city that we were able to offset some of these capital fees through a system development charge type of process. Project status, just a quick update. The interconnecting pipe and pump design's complete. We're hoping for a bid opening very soon, Q3. Wellfield expansion and water treatment facility rehabilitation design may be starting soon on that. It sounds like from the wastewater side, 2 of 3 phases of the wastewater treatment facility have been improved and rehabilitated. We're moving through the last phase now. And then we'll be ready to bid that. And the lift station evaluation and pump replacements, that project is complete. Just some quick pictures before and after. Of course, these primary clarifier pictures are really bad because it was out of service, so it's been left sitting. But very nice looking rehabilitation, non-operational to now operational, similar picture. This is some of the work going in, new generator, new screens that have made a huge difference to the wastewater plant, coming back in with fine screening, some of the head house and digester piping replacement, and new conduit, duct bank. Challenges that we faced on these particular projects. COVID-19 made things very, very difficult for us, both from the typical bottlenecks that everybody has recognized, but also from the inability to get labor to the job site for bid day. We bid it 3 times, and the first 2 had no takers, and on the third one finally received bids from 2 contractors. Really tough. Maybe my hardest bid day challenges in my 28-year career. The value engineering effort came after we busted budget due to the inflationary issues at the time on the first 2 phases of the work. And so did some value engineering and got the project back flowing and are set up now for the 3rd phase within an overall budget structure. And the GFA loans, the concept of doing work out at the wastewater plant, but working it through 3 different GFA loan and grant combinations, just provided some challenges to us on construction timing and the usability of funds. Our overall takeaway from this effort with the city, the comprehensive planning process worked. Our community partners, whether it be GFA or the South Georgia RC or with this DCA initiative through the Plan First community concept, we constructed meaningful projects for the city of Waycross, and a lot of these are still ongoing. Probably we'll have an update to this capital plan in the next year or 2, trying to keep up with it. The overall takeaway from this project structure is that this overall effort supports to the regional initiatives for growth and economic development. We're always trying to have better facilities, more reliable facilities, and more redundancy. And this one checks all of these boxes along with supporting economic and regional efforts. And then just to talk about our city partners, as I said, DCA, South Georgia RC, GFA, all participated in some way. We were the engineers. Infomark operates the wastewater and water facilities for the city of Waycross. And of course, the commissioners, Mr. Rayford, the city manager, the planning department, with Mark and the mayor, all have been big supporters of this work. And we are awfully proud of being involved from my perspective and just continuing to promote the city of Waycross across the region. Daniel.
That's great, Trey. Really appreciate you speaking on that. Great projects. I'd also just like to put a fine point on unashamedly plugging the Plan First program, which is another program that I manage. The numbers that I have on two of the loans from GFA, as DCA shares a strong partnership with the Georgia Environmental Finance Authority, we have offered 0.5% reduction on GFA interest loans. So what I'm seeing and what I saw was that out of the two loans of $3 million over 20 years, that 0.5% reduction, because Waycross was a Plan First community, they're saving roughly $164,000 over 20 years, and that's real money. I mean, that's, if you're a planning director, that's certainly more than your salary. So great job with the city of Waycross partnering with the Southern Georgia Regional Commission in accessing that Plan First incentive, and great job to you, Trey. Thanks for explaining what you guys have done, really improving the water quality over there in Waycross. And with that, we are going to provide a little bit of time. I think, Julie, we did have a question of our previous speaker, Melanie, if you could bring that up.
Yeah, certainly. So, Melanie, if you are still around, we've got a question for you. This is from Paul Gerald, and he asked, we have a community that has water quality issues. Is that on the filtration side or the inflow side?
Hey, yeah. It's kind of, I guess it would be tough to answer if is it, I guess, water quality post sewer treatment or post water treatment. Um, I assume that he's saying I'm going to answer this as it's post water treatment. And so, yeah, it could be on the filter. It, probably is on the filtration side. Right now a lot of people, if you have kind of your older gravity sand filters that they aren't being as productive if you aren't keeping them up to date. So that's why a lot of our communities are going to membrane technology. But that would be a question I have to get in a little bit deeper with you. But Paul, you're more than welcome to email me or call me, and I can listen and hear your concerns and maybe answer it that way.
Thank you, Melanie. I think that's the only question we've had pop in so far. So back to you, Daniel.
We'll give a few minutes for folks to get their questions in. I know there's a little bit of a delay. So any questions of Trey, Gavin, City of Waycross? We have also Charlie Bridges, who's also from ESG Engineering. So they've got a team available and ready to answer any specific questions about that project in Waycross.
Seems like this is going to be an easy day for me, huh?
Hey, Trey, you might have a question that comes in a couple of minutes, and feel free to ask those questions at any time, guys. Julie
It looks like, sorry, we just had two pop in.
There it is. There
we
we
just had to
go.
marinate for a second. So John Boyd asked, are there any concerns with PFAS in Waycross?
Not presently. I think we're all concerned about these emerging contaminants across all of our systems, but we have not had any hits for any of the testing that we've done thus far. So it's good news. I mean, at some point, we're expecting it to be everywhere. I guess you are all in the middle of it, and we've kind of formed a national task force to try to make sure that we're at the front end of this. But currently, we are not in a situation in Waycross where we're having to jump on this as a primary issue.
Thank you. And one other from Alexandra Arzeas, I think. You mentioned GFA and grants. Do you all anticipate any changes to funding after the budget was recently passed by Congress?
Well, we keep pretty close to this. I think it depending on when how much information you had previously, then there were changes in my world. No, recognizing that it does seem like we were well funded. GFA was well funded in the last legislature meetings, and so all good news from our front. I think it continues to be a competitive program, and we're just happy to see that funding did flow back into GFA coffers, and it feels like it's good news coming from the state funding group right now. So I don't know if that answers the exact question, but I think it's better news than last year, and probably similar to what we have become accustomed to from GFA's ability to be able to fund projects.
Thanks, Trey. I think that's all we have for now.
Sure
Yeah,
thing. And if more comes in, y'all just shoot me a text or something, and I'll be happy to help out through you.
Will do. Oh, hold on. We may have had one more.
Okay.
Lee Spell asks, is Waycross using UV treatment? Also, hello, Trey.
Hey, Lee. No, not UV. For waste, I'm assuming he's talking about wastewater treatment. No, it's a very different kind of treatment system. Go through tertiary filtration and then go out to a what's called a RIB site, rapid infiltration, kind of almost like a sand filter that's built as part of a land treatment system. So not something I had run across a whole lot before working for Waycross, and a very interesting land treatment concept that where we use in situ sand to be able to treat and have under drains to be able to finish off the water. After that, it's chlorine disinfection.
Thank you. Okay, now I think that's it.
Great. Thanks again, Trey. All right. Well, we're going to move on to the city of Cochrane. And we have the city manager of Cochrane, Mr. Richard Newburn, who's been at the helm there in Cochrane for almost 11 years. And they're going to be talking about their Phase 2 sewer rehabilitation project. That was a citywide project, a little over $1.1 million, improving their city sewer collection. So, Richard and Lisa, I'll let you guys take it away and promote you to the big screen.
Okay, thank you. Appreciate it, Daniel. And we have our presentation. The wanted to say that our efforts were concentrated on slip lining of our sewer system, which was highlighted in our city county comprehensive plan, both in 2016 and also our plan that we worked with Bleckley County on in 2021. A little bit about the city of Cochrane. We're located in Bleckley County, Georgia. We're about 40 miles southeast of Macon, about 30 miles west of Dublin, really just south of Warner Robins. We're about a little over 5 square miles. Have a population of a little over 5,000 people, and we're the only incorporated city in Bleckley County. We're a charming rural community, relaxed rural lifestyle, yet we have our challenges with water and sewer. Our Similar to Waycross and other municipalities that have reported, we have a waste treatment facility where we've had a great deal of inflow and infiltration. But a little bit about our plant. It's a modern tertiary plant built in 2002. We process about 430,000 gallons per day. We have SBRs, or sequencing batch reactors, filters, and we do have UV disinfection on site. That was installed about 10 years ago, the UV disinfection. We maintain 5 lift stations as part of the wastewater system, and we inspect each of the lift stations every morning or 5 days per week. Our dewatering is through a belt press. We don't have a screw press, but we have a belt press that we use for dewatering. Total in Cochran, there's a map of the city. We have 27 miles of sewer lines. Much of the waste treatment infrastructure, similar to other cities, was built in the 1950s and 60s, not too long after World War II. With age, sewer lines commonly experience corrosion. We've had joint failures, pipe separation, and just like the picture from Waycross, just a deterioration of our sewer lines. And so we really have grappled with how to best approach this. It's like I mentioned, it's been a goal in our community work program in our 2016 Cochran-Bleckley County comprehensive plan, and then again in our 5-year update in 2021, and that is to conduct and repair our sewer system. So in 2018, the city of Cochran completed a comprehensive condition assessment of all 27 miles of sewer collection in town. And so Falcon Design and Consultants, they're out of Stockbridge. They've been our sewer or our consulting engineer really for about a little over 11 years. And so we did a complete comprehensive condition assessment. It was a very thorough assessment of the location of our all of our manholes, the condition of our sewer lines. I know in city of Rome, it was reported earlier that they discovered some holes in manhole covers. Well, in the city of Cochran, I don't like to boast about this, but we discovered some manholes we didn't even know about. Yeah, I mean, there were a couple there that were surprising. And so they were taking on some infiltration. But that's what the comprehensive condition assessment does. The advantage, and I recommend it to any town of any size, is to keep up and identify and inventory the system on a regular basis. We identified 6 miles of sewer lines serving residences and businesses that were deteriorated in need of repair and replacement. So we looked at traditional work of replacing the lines. That's a lot of excavation. That includes traffic disruption, property damage, a lot of expense. But then we pursued what has been around for a while now, slip lining and cured in place pipe. This isn't new among cities and counties, but it was new for the city of Cochran in 2018. And so we pursued the trenchless pipe rehabilitation method. We actually approached it as a geothermal compound that would be pumped into the deteriorated sewer lines. We put together a budget and we made a proposal to GEFA, Georgia Environmental Facilities Authority. And we obtained a $2.5 million loan through GEFA to finance this and other infrastructure improvement projects. The loan was given at a 1.3% interest rate to be repaid over a 20-year period. And we did enjoy a loan forgiveness, not as much as the city of Waycross, but we did qualify for a 20% forgiveness. So you may hear about GEFA. They do offer grants. Well, I learned that it's really a grant on the back end in the form of loan forgiveness, but it still was a big advantage to us. That 20% loan forgiveness was really a grant to the city. We bid it out. Falcon Design actually assisted us with bidding out the slip line proposal that was funded by GFA. We received 7 competitive bids and then decided on the contract with the Rene Group out of Atlanta to actually do the slip lining. And you can see some pictures there of them, the Rene Group in town, actually pumping the geothermal substance compound into the city's most deteriorated sewer lines. And it was over a period of probably 3 to 4 months where they did the work, about 3 months actually, and it greatly improved the reliability and efficiency of our sewer collection system. And that was our goal, to improve the functioning of our sewer collection, reduce the inflow and infiltration. And so we were able to accomplish that through this project. The city leaned on combined efforts of different organizations. We collaborated with, again, Falcon Design Consultants. They helped us with the design and the inspection throughout the process. GEFA, Georgia Environmental Facilities Authority, they've been a great resource to the city with regard to financing. The city council, the mayor and council, city of Cochran, we appreciate their leadership and their interest in making this program work to improve our sewer collection capacity. And the City Public Works Department has also helped us. The Rene Group did a great job with this project, and so it was a great program. We're still enjoying the benefits of it. Now, I do want to mention Plan First. We were a Plan First community. We became Plan First after GFA awarded the loan, so we didn't enjoy that 1% reduction or that percentage reduction in the loan. But Plan First does come in handy. We've actually taken advantage of Plan First with our downtown businesses, the Downtown Development Revolving Loan Fund. That's helped us. That reduction in the interest rate has helped several businesses down in downtown Cochran. Takeaway on our sewer project is it was a success for the city. It's resulted in a more efficient return flow to our waste treatment plant, and it's extended the life of our sewer infrastructure. I mean, here we are, over 20%, over 20% of our infrastructure, our sewer lines have been greatly improved. Now, we did learn the value of a thorough pre-construction meeting and the importance of community education during the project implementation. We were on Facebook. We put out door hangers with regard to when the Rene Group would be in a particular neighborhood. I think we could have done a better job even. You have to really make sure that people are contacted. We did receive some phone calls, people saying, well, who is these 2 construction crew workers in my backyard? And I'll say, well, they're looking at the manhole back there. They're part of the Rene Group. They're doing improvements. And so one takeaway is make sure the community is contacted. We did have a lot of community support. I think by notifying different neighborhoods, exactly where the contractor would be, that's an important element of getting the project done. Now, we have ongoing efforts with our sewer system funding. In 2024, last year, Senator John Ossoff secured a $700,000 grant through the congressional budget allocation to be used for wastewater improvement projects. It includes our major lift station at our lift station or at our treatment plant. And that lift station is in great need of repair. And so that grant is going to help us out tremendously, as well as we're going to put our belt press in the blower house to protect it from the elements. So ongoing, we're seeking funding to improve, preserve, service our sewer system for the benefit of the citizens. So that's our presentation, Daniel.
Thank you, Richard. Nice job. Really enjoyed that. Thanks for the plug on the Downtown Development Revolving Loan Fund. That's great. Love to hear that. Yeah, and so this goes to show you that a size city similar to Cochrane can be innovative, and you guys have done a really great job with the slip lining and really ensured the future water supply is going to be strong, and you're going to be confident in your water supply moving forward for decades to come because of this.
Yeah, sure. I'll be happy to answer any questions.
Absolutely. Yeah, this will be your time. We're going to pause for a little bit and let you guys get your questions in of Mr. Richard Newbern, City Manager at City of Cochrane.
Okay, it looks like we've got a question here from Tom O'Brien. So what do you do with your sludge after pressing?
We haul that off. Our contracted waste hauler actually transports it to Houston County, north of here, about 30 miles. We do have a licensed transfer station in Blakely County, but it can't be dumped there, so we pay to haul it off. It's actually the sludge is put in a 20-yard roll off, and when it's full, we'll have the waste hauler take it to Houston County to the landfill that can accept it.
And Marcus Meconico asked, what convinced you guys to do slip lining?
Well, really, it was appropriate to the need. After considering that technology, it was going to address the porous nature of our sewer lines that were in the worst condition. So that was the fact that it was the answer technologically, and also the cost was reasonable. It was something that we could afford within our GFA budget.
And a follow-up to Tom O'Brien's question about what you do with your sludge after pressing, he'd like to know what the cost of that is.
Oh my goodness. Hauling off the sludge, that takes place. It's probably about, I'd say, probably a couple of $1,000s a month. That includes hauling it and the disposal fees at the landfill. But that's really, I don't have an accurate figure on that, but I believe just looking at the tickets from that, it amounts to probably 25 to $30,000 a year. So in that neighborhood.
Thank you, Richard. Those are all the questions that have popped in so far.
Okay, we
Let's see.
appreciate it. And you can, if anybody has any other question about our slip lining that we did in the city of Cochrane, and the results, please text me or send an email. I'd be happy to correspond with you.
Thank you, sir. Appreciate that. I just posted up in the discussion at the top of the Q&A all the speaker contact information. If you would like to follow up with these individuals speaking today, any more detailed questions, that's their information there. I do apologize. Earlier, I did say that you could access the chat. That just shows you that I didn't quite understand the Microsoft Town Hall function, and you do not have access to the chat function, but you do have access to the Q&A. So please avail yourself of that with any questions. And we are going to head over to the Northwest Georgia area of our state in the city of Dallas. And we have Miss Keisha Moore, who is the Economic Development and Community Development Representative from the Regional Commission of Northwest Georgia. We also have a City of Dallas Representative, Miss Amber Wisner, who is going to be able to speak on the City of Dallas's advanced metering infrastructure project that they implemented just a handful of years ago. So I'll turn it over to you, Keisha and Amber.
Thank you, Daniel. I'm going to share my screen here. Can y'all see it okay?
We do see the PowerPoint.
Gotcha.
There it
All
is.
right.
Perfect.
Perfect. So yeah, like Daniel was saying, my name is Keisha Moore. I work for the Northwest Georgia Regional Commission. We cover 15 counties and 48 municipalities, Dallas just being one of those. Of course, Amber's here to chime in at any time. This was her baby, so I hope I do it justice for her. So we're going to talk about advanced metering infrastructure. So I think we can all relate to one of these things on the screen. Perhaps it is Spaghetti Junction on a Friday at any time of day, being busy. And my personal favorite, people not knowing the difference between there, and there. But for Dallas, it was, high water bills, faulty meters, and that sort of thing. So a little bit about Dallas. It is 38 miles outside of Atlanta, Georgia, in Paulding County. As of 2024, their population is approximately 15,000. Some of the historic things around Dallas, the Dallas Theater, and of course the Silver Comet Trail in Paulding County as well. So what is advanced metering infrastructure? Advanced metering infrastructure, or AMI, that I'll refer to, is a system of water meters, remote data collection services, a network system that provides a two-way communication between utilities and customers. So it can detect and diagnose leaks, schedule conservation programs, and improve customer service all around the board. So AMI changes everything, but how exactly does it work? The city of Dallas saving gallons of water per month using AMI. So this is a picture of kind of how AMI works. So we have a antenna going from, the regional network interface or their computers in the city of Dallas. You have your smart meter at your home and kind of an antenna bouncing off those things, so they don't have to bring someone out to your home to check that thing. They can check it remotely and figure out what's going on. So it's real-time usage at the meter, and they can notify customers of leaks within days or weeks of onset. And it's also educating customers on conservation as well. So why AMI? So it gives their customers more accurate readings on their water usage. The city of Dallas has the ability to alert customers when there's a problem. and it provides a more sustainable measure for the environment. It also allows their customers to handle any problems before their 30-day bill comes. If they have a child in their house that's taking too long of a shower, there's a leak, anything like that, this prevents it. So I want to talk a little bit about their comprehensive plan. As we all know, whenever you're applying for funding, it's important to have it in your comprehensive plan. So the City of Dallas had a water quality and water conservation mentioned in their last several Paulding County comprehensive plans. This allowed them to have the flexibility to pursue funding options, one of them being AMI. So proper planning is necessary to have a successful project, and I think we can all agree on that. This gives a little overview of the City of Dallas's system overview. There was 38 miles of water line, 3,700 water connections. Of course, we mentioned earlier 14,000 in terms of population. 21 county interconnections of water purchased, 3 wells, and some stats in 2016. The total water supplied was 205.733 million gallons. Real water loss and apparent loss are on there as well. So when they had their audit, it made it very clear that there was flaws in the City of Dallas's system. They scored a 64 out of 100 on their audit score. Their net loss was about 31.34 millions per gallon a year. And then you can see that charted in this slide. So what does the audit tell us? More particularly, it asks us, am I losing revenue? Do I know where the loss is? How can we gain revenue? This shows a blueprint of the water system. As you see at the bottom, I know it's really hard to see, but this is their audit score, 64 out of 100. How much is leaving the system? And things in the audit system that can help improve the system. So the City of Dallas implemented a zone water loss program in 2024. And that motivation was driven from the results of their 2012-2013 water audit. The City of Dallas wanted to minimize the amount of water lost in the entire system, and complete system was separated into zones. And each zone was based off of data, development variability, and the ratio of loss per address. So this is a map that shows how the system is set up to work. I know the text in the upper left-hand corner is kind of hard to read, but the green is customer meters, DMA flow, which is district metered area, and then the blue line is the utility water line. So this map is showing a system of how everything works. Each customer has their own meter that runs to the DMA or district meter area, flow meter. Roughly, it's at the end of the street in this illustration here. The DMA flow meter determines how much water is flowing into each DMA and compares that to the billing volume. And it helps determine if there's a leak somewhere in the district metered area. So these are the types of losses that we have here. There's real losses and apparent losses. So real losses are pretty self-explanatory, caused by physical losses of water. Typically what happens, as we stated earlier, when your child's taking too long of a shower, or a leak in someone's house or in the water main. That's the real loss. The apparent loss is meter under registration, water theft, or billing errors. So those are the differences between the two. So Dallas put in a meter replacement project. The project began around 2015. 12 to 15 years is a new meter life cycle. Between 2018 and 2020, all meters were replaced during this time and were fully operational on the AMI system. And their next phase, they're going to be doing a meter replacement program in 2027. So this is kind of a breakdown of the city of Dallas's what they see on their end. So the system automatically alerts to potential leaks in the district meter area. It also alerts to high flow areas, places where the meter's fallen out of communication with the system, all those kinds of things. So it's very handy to have. So some of the corrective actions taking place in the city of Dallas, we have meter testing. They're going to be done on a regular basis on both the older meters that have not been replaced yet, as well as the new electronic meters as precautionary. Leak detection, as this DMAs are completely transferred over to EMI, leak detection should be done more frequently. Pressure management and monitoring, they will set up pressure monitoring areas in each DMA using Sensu products that connect with the AMI analytic software so that regular monitoring and management can take place. And then they will utilize the component analysis tool through the American Water Works Association for additional steps and courses of action. So the city of Dallas has had much success with this AMI infrastructure in their city. They expected to drop a water loss from roughly 47 million gallons per year to less than 10 gallons per year. So it's a pretty awesome system they have in place there. So I know what you're thinking. Keisha, that was great, but how do we find more information about City of Dallas? We want it in our community. I'm glad you asked. This is a slide that shows many articles of how they did what they did. And you can click on those at your convenience. And that is all I have. If Amber wants to add anything, but thank you guys so much for listening.
Keisha, thank you. Amber, anything on your end?
I will add just a few. Great job, Keisha, on presenting that. Man, 10 years. That went fast. So the majority of that presentation was when we first started AMI. I would just like to say jump forward to 2024 where we were supplying 328 million gallons of water with over 4,000 water customers connections. So all in all, we are 100% AMI. We put that in place to prepare for the future, and it did exactly what we thought it would do.
When a plan comes together.
Absolutely. And that was a big plan. That was a big plan and a big, we are what I still consider a small utility. And I always say small utilities can still do big things. You just got to have the right plan in place. So that's one of our prizes we have. A lot of us work to make that come together and be fully operational. Yeah, I will add to this because I know some of the other presentations talks about grants and funding. We self-funded that entire project in-house. So just by doing it in phases and replacing the meters and fixing the apparent loss, we were able to completely fund the full meter replacement project and the towers and the system all in-house.
Anybody with any questions? We have plenty of time. I'd scheduled this to go all the way until 11:45, and miraculously, this never happens to me. We actually finished earlier than I anticipated. So plenty of time for you guys to noodle and think about your own communities, what advanced metering infrastructure might look like in your own towns or counties. We've got some experts here on the call, so post it in the Q&A.
Okay, so it looks like we've got a question from Marcus Mecanico. How have the citizens reacted to the AMI system before installation and after?
So that's a fun one. In the beginning, it was tough. It's, anything computer related can make people feel a little weird. I think when customers would call in, and as far as the transition, just to replacing the meters, anytime someone's out there messing with something in their front yard, they're going to call in. So we really did educate our customers on what we were doing and that they would have better real time experience. Just as a kid leaving a water hose on, as a mom of 4 kids, I completely understand that. As we got the system implemented and someone would call about a high bill, and we would pull the data and we would say, well, it looks like, you have a toilet running, right? Like the flapper's hung on it, so it runs about 230 to 50 gallons an hour. They don't like when you know what's happening in their house. So I think that was the biggest transition for us, is just getting them to understand that we're not sitting there looking at seeing what everybody's doing in their house, but we're going to use this as a, so to speak, financial water guide. What they did find out is that their teenagers were taking an hour-long shower when they thought they were in there for 15 minutes. I will say that one of our greatest successes is because we were able to integrate AMI with our customer portal where they pay their bills and they're able to see it on one screen. We actually have about a 96% adoption rate of online e-billing because they can see their customer usage. They can set alerts when they go out of town. If they know they're going to be gone for a week, they can send an alert that says if it uses more than 2 gallons, send me an email, send me a text. And I actually have the notifications on a few fountains we have downtown. And when it goes over that threshold, I get a phone call, an email, and a text message all simultaneously telling me how many gallons was used, that it crossed that threshold. So it did take us a little while, but now the customers love it, because if something leaks, instead of us calling them a month down the road or them calling when they get the bill, they call us immediately and say, hey, my water pipe busted yesterday. Can you tell me how much that's going to make my bill go up? So we also implemented an ordinance that if we notified them of a leak, I'll preface it with this. All of our water customers are on sewer as well. We only have about 75 customers that's on a septic tank. So we would give adjustments, and typically that adjustment comes in the form of a sewer credit. But if we notified them and they had a leak and it was not fixed within 2 weeks, even if it was unless it was like a just extreme circumstance, they would not receive the credit on their bill. So it was kind of to push that information.
Question, Marcus. What else?
Okay, so Michaela Brown asks, how does AMI work in the event of a storm? Excuse me. Does it have backup power somewhere?
So I will say that I don't 100% know the answer to that question, other than the fact that we've not had any issues with them going down. I will say that when we lose some, there are generators, or I'm sorry, let me rephrase. There are battery backups on the 2 antennas that we have. When one of them goes down, within a couple of hours, we get a notification from Xylem telling us that we have a tower that's down and to send someone out to check it. And typically it's just either something's come loose or, again, battery needs to be replaced. But overall, we've been AMI since 2017. I believe that's when our first tower officially went up. And I can't recall a single time that we have had a huge issue. Our billing clerk reads 1 cycle a month. She hits the button and the readings are in the computer in about 45 seconds. There are times when seasons affect it. So more so over the antennas going down, it's leaves piling up on top of the meter box, or if we have a rainy event and water has gotten into the meter box, that's what we find more commonly affects the reading. But within a couple of days or sending a guy out there, we typically can fix it.
And following up, Marcus Mecanico asks, are there any issues with the new meters? I know of a community in South Georgia where new meters could not take the heat and they started to burn out.
So we haven't had any issues per se here in Dallas. We've gone through over the last couple of years. I wouldn't say we ever had an issue with heat. Ours is snow and ice and just where they're located in the meter box. But overall, just here and there, we had to replace. We're still on track to start that replacement program in 2 more years. Probably could get, these meters were supposed to hold a 20-year battery, probably could get quite a few more years, but I don't want to be in a situation where they all fail at one time or they all go dead at one time. So nothing for us would say anything different than the meter we chose to put in place. There was a specific reason for that. But overall, it's been fine. It's technology, so you're always going to have an issue here and there with technology, but overall, we're happy with what we have.
Yeah, having worked in Hiram and Dallas, and then having married a woman from South Georgia near Valdosta, that's a different type of heat in South Georgia. I'm telling you, it's a different type of heat. Give a few more seconds here to any last burning questions. All right, guys. On behalf of the Department of Community Affairs, Julie Yoder and I thank you very much for attending today. A very warm thank you to Amber Wisner, Keisha Morris, Miss Lisa, Richard Newbern, Trey Gavin, and Melanie Bruggeman from for all of you contributed in a very meaningful way to this presentation today. I know a lot of our local governments have enjoyed learning about this and learning about what's happening in different parts of the state. And we're grateful that you all took the time to present and provide these presentations. Again, as a reminder, these presentations will be made available on our Planning Success Stories website, which I did drop the link there by the end of the week. So we're getting started right away on getting those uploaded. And if you have any questions about our planning functions at DCA, feel free to reach out to planning@dca.ga.gov. And again, I did provide those email addresses in the discussion so that you guys can access that if you have any specific follow-up questions with Melanie, the City of Cochran, City of Waycross, and City of Dallas. Thank you all for coming, and I wish you all the best. Please tune in September. Be on the lookout for another email coming from me. We're going to be doing a housing-focused success stories in September. So be on the lookout for that, and that'll be our third of our 4 quarterly webinars in the year of 2025 from DCA Planning. Have a great day. Thanks.